Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. I do have videos that I need to make for the classes that I teach, and other videos that I want to make because I think they're interesting or important topics. But occasionally I do get a comment or question from a person on one of my videos, and that leads me to create a new video. And I'm really happy to do that. If I can answer a question in a video and I think it's going to be interesting and informative, I will. So first of all, thank you to Shadow or Anthony for asking the question on this video, which is 5 cool uses for pygame masks. So the question had to do with, can you use a mask to change the appearance of a character? And I am going to do that. I've got 2 different examples, but we sort of got into a conversation about sprite sheets for animated sprites. And so I'm also going to show you an example of how to have sort of parallel sprite sheets so that you can blit equipment over a sprite and have the animation still look good. So we're going to do those 2 things in this video. I did want to mention, this is my GitHub repository, and this example, which is listing 1013 in the Chapter 10 textbook code from the Python Objects and Games book, or directory here in GitHub. This example is an example of a platform scroller, and it has an animated sprite in it. And I do the animation a little bit differently here. It's one image, and I just pull the different frames of the sprite out of the one image. So that's different from how I'm going to do it in this video, but I did want to just mention this example, and I'll include a link to this in this video, in the description of this video, so that you can look at this example too if you're interested in a different way to do a sprite sheet. So the first part of creating the animated sprite is, of course, the graphics, and the graphics are really important, and I am not an artist. So I went looking on Vecteezy for a sprite sheet, and I found this one by Graphics RF, and they have a lot of great stuff. This one happens to be free, and it looks like just what I need. So I decided to work with this one. And so the first thing I did was remove the background and remove the text and make the image a little bit smaller. But I'm going to pull each of the child images out of this and make them each a separate image. And you can see here they overlap each other a little bit. So with this exact image, I would not have been able to do this in the same way that I did the penguin in the textbook, in the example in my GitHub repo that I just showed you. So I'm just going to pull each of these images out into its own separate ping. And what's important here, first, to make this easy on yourself in the code, is that each ping is exactly the same size, and that the picture of the sprite aligns with the other sprite pictures within the image. So you can see when I paste a new one in, I'm just pasting these all in Photoshop as layers, and when I paste a new one in, I'm aligning it by basically the bottom of the head and the shoulders, and I'm making sure the feet and the top of the head are within the frame. And I'm using transparency to get that aligned. Now the reason I'm saving this out as a PNG is because it has an alpha channel, transparency channel. And you can see that when I save these out, I'm saving out just one frame of the sprite, no background. So where you see that checkerboard pattern, those are all transparent pixels. So when I blit that, as long as I convert alpha when I bring them in Pygame, when I blit it, those bits would not blit as anything. So only the pixels that have a color are going to blit. So that's important. Having them the same size is important, and making sure they align is important. But then, because one of the questions is about equipment, or I interpreted it as being about equipment, we're going to have parallel sprite sheets, one of the sprite and one of the equipment, I decided to remove the hat and use my limited artistic skills to give the child a head of hair and make the hat separate. All right, so what I did once I had the child just without the hat on is I made a separate set of sprites for the hat. So for each sprite in the original child sprite sheet, I have another sprite, again, the same size, which is the hat, in the correct location so it looks like it's correct on the child's head. And then I decided to just find another hat. So this same artist created these cool, I think they're called hipster hats, which is why I'm calling it a hipster hat in the code, created these cool hipster hats, and I just grabbed that green one from the upper right. And then I didn't record this, but because the hats don't really move that much, the head is pretty stable, and in fact I didn't do a great job with the hats. You'll see they bounce a little bit when the character moves. I decided to add a glove that goes with this green hat because the hands do move a lot in the different frames of the sprite. So I gave it just like one little fingerless glove so that you can get a better idea of how these sprites look. All right, so this is my folder of images. It's called sprite_images. And you can see, let's do extra large icons. Okay, so you can see here's the character, and there are 6 different frames, although I think some of them are duplicates. Like I think 3 and 1 are the same, and 2 and 5 are the same. You can see just the plain hat, the original pith helmet, I think it is, or bucket hat, that it was wearing are basically the same. And the same thing with the green hat, but I added the glove in with the green hat, so you can see the position of the hand is different in each of these. All right, so these are going to be loaded into parallel lists. All right, and here's a nice sort of representation of parallel lists. So remember, a list is a collection type, and it is indexed. So you use the index of the element to get at the individual element within the list. Well, for 0.png, which is the child in 0 frame, you use green hat 0.png. So this will be at index 0 in my list for this hat, or hat 0.png. This will be at index 0 in my list for this hat. And for the child, which is 1.png, you would use green hat 1.png or hat 1. For child that is 2.png, you would use green hat 2.png and hat 2.png. So this is a nice visual representation of parallel lists. Parallel lists are linked by, or the data in parallel lists are linked by the index. So the child at index 0 relates to the green hat at index 0 and relates to the bucket hat or pith helmet at index 0 in the 3 separate lists. All right, shall we look at the code? So I did write 2 separate programs, but the bones of both of these programs are the same. So I just wanted to separate out the mask change from equip just for clarity. So I'm going to run each of them just so you can see what they do. So this is equip sprite.py. Okay. And it's pretty straightforward, just arrow keys to move, spacebar for appearance. And by the way, there's no boundary checking, so you can walk this sprite right out of the window if you want to. So I'm going to press the right arrow, and I'm going to press the left arrow. Okay, spacebar for appearance, so I can change, it just toggles through the different hats, or no hat. And again, notice with the green hat, there's the little glove. So as the character moves, and it moves a little fast, and I always have it, when it stops, I always have it go back to what looks like the most resting position to me. Probably need a resting position, but so it's a little bit hard to see, but the glove is always moving with the hand. Okay, so that's equip sprite. Then this other one, I think is fun. Well, I'm still calling it equipped sprite, but this one, the program's called mask change sprite.py. And with this one, I'm using a mask to change the sprite's hair color. So same thing where, you can press the right and left arrow keys to get the sprite to walk in the 2 different directions. But if you press the space bar, the hair changes color. And I'm doing that with a mask. And I just picked a random color. I just think that's so much fun. I just love random. And you can see all of the frames change color. It does slow them down a bit if they're walking and I change the hair color. And also, I didn't try to do a big change. I mean, this is just an example. So you can see with the hair, it has some shading in it. And I just took, when I made the mask, anything that was within a sort of yellow threshold and made that the mask. So it all gets replaced with one color. But you could certainly get more subtle with that, or do this in a different way. Again, it's just a demonstration. So let's start with the mask change sprite program. This is closest to the original question, I think. And I'm not going to go over the whole program. This will be available in my GitHub repo, and I'll have a link in the description. I'm going to focus on the mask part. And I do also want to say this is not the most efficient way to do this. As I noted, it does slow our sprite down if we change the hair color while the sprite is walking. The better way or more efficient way to do this is with a pixel array. You want to get down to the lowest level of manipulation because we're iterating over a two-dimensional array, which takes time. And I'm doing it in a slower, more object-oriented way. But I think that it's clearer, and I want this to be clear how we're doing this. Okay, so the character is of class equipped sprite, and I do have parallel lists here. So I have a list of images, and I have a list of masks. Okay, so let's look at that first of all. Remember that the images are named 0.png, 1.png, 2.png, etc. A file name is just a string. So what I can do is build up the name of each of these files and load them in. So in a loop, I'm just loading. The folder is called sprite images, and the program is in the same level, at the same level. They're both in my folder here, which is called equip sprite. So we go down into sprite images, and then we're using an index, so 0.png. So we're building up that file path and loading it in and then doing a convert alpha. Because remember, we're using PNGs, which have an alpha channel, which is that transparency which we want. And then I'm just adding that image, appending that image to my list of images. So this is going to be at index 0 in the list, index 1 in the list, index 2, 3, 4, and 5 in my list called self.images. Then I'm going to make a mask of just the hair from the image using mask from threshold, which I used in the other video to create the pointy part or the dangerous part of the axe. So for that we pass in the image, and this is the color, this is the bright yellow in the hair, and this is the distance that this darker yellow is roughly from the brighter yellow. So I wanted to get both the bright yellow and the dark yellow. So we're going to make a mask which should be just her hair. Nothing else is yellow. And image index 5 is the one that I thought looked the most resting, so that's where we start. Okay, so that's part of it, is that we have these parallel lists of image and hair mask. Now, the other part of it is this change hair method. So when the user presses the space bar, we call the change hair method. And this is going to iterate over every single image in the sprite sheet. So for each of these images, we first generate a random hair color, and we're going to use that same random hair color for all of the images. We're going to copy the image, and then we're going to iterate over every single pixel in the image. If we look at an image in Photoshop, zoom out for just a sec. Right, so here's our image. You can see the pixels, right? There are these little squares. There are a lot of pixels. So this is intensive. But we're going to iterate over each of those pixels, and this is why you want to do it in a more efficient way with the pixel array. But for the sake of it being super clear what we're doing, for every row, for every pixel in every row, if that pixel is set in the mask, so in other words, if the mask is there, then we're going to set that pixel's color to the randomly generated color. And we're doing that for all of our sprites in the sprite sheet. So as soon as we press the space bar, suddenly all of the sprites look different. And that's why it happens to press the space bar and the hair color has changed for all of the sprites in the sprite sheet. Okay, let's look at the other example. And this one is using the parallel lists of sprites and hats. Okay, so I have these three lists which are part of the sprite. Images, which is the sprite image, pith, or bucket, I don't know what that, I think it's a pith helmet, but these images, wrong one, and hipster, which is the green hat and the little glove. Okay, so when we create the sprite, we create the three empty lists just like before, we're going to iterate over the 6 images that we have and build the name of the image, load it in, convert to an image with an alpha channel or surface with an alpha channel, and append it to the list. So that was the same as the code in the other example, but I'm also loading in each of the hats. And again, very important to convert alpha so that the whole image is transparent except for where the hat is. And again, setting those all to a resting state. Then I call this create image. This is just going to pick the image for where we are in our animation. So I keep track of the animation with an image index. So we just make the image whichever image we are on in the animation. And then, depending on what type of hat we have, we grab that parallel image using the same index from that list and blit it onto the image. So if we're at index 3, we go into index 3 in the images list, which is this image. That becomes the current image. We make a copy of it, and it becomes our current image. And then we go into index 3. Let's say we have the hipster hat. We go into index 3 of the hipster hat, which is correct for the position of the sprite, and we blit that on top of it. And because it's transparent, because it has an alpha channel and it's transparent, wherever the hat and the glove aren't, it will just blit right over the character and it'll look great. So that's really all there is to this. There are a few other little things. The flipping left and right is done after the image is created. So after we put it together facing right, if we're facing left, then I flip it. The reason I have a facing right Boolean, and I'm not just using the dx, which is negative when we're walking left, is because the dx is 0 when we're stopped. And I don't want the character to suddenly change their orientation just because they've stopped. So I want them to continue to face in the same direction. Okay, and what else? So a process move command is really just maintaining some variables. Change hat just changes a variable. And that impacts, so it just changes the current hat variable. So that just impacts what gets blitted over the character. So this is actually pretty straightforward. I think the trickiest part is understanding the parallel lists, which again, you can get kind of a nice visual representation like that. Each of the 3 lists, now that you've seen the code, all right, this is the images list. Down here is the pith list, and up here is the hipster list. And then we have the image index. So if that's 2, then we copy this. And then if the hat type is hipster, then we blit what's at index 2 in the hipster list over the image. If we're at image index 5, we copy this image and blit what's at index 5 from the hipster list over this image. There's the base image with the pith hat, with the hipster hat. There. Well, I hope that you found this interesting, and I hope it's helpful in particular for Anthony, that it maybe answers some of your questions. It was your idea to use the mask to change the character's appearance. I loved the idea, and I thought it was so much fun to change the hair color with that mask idea. So I think that probably has a lot of really cool uses, and then I would not have shown equipping a character with parallel sprite sheets like this if you hadn't asked about it. So I'm really happy to have created this video, and thank you for the question. For everybody watching the video, as always, have fun and keep coding.